ELI5 an increase in temperatures by just 1 to 1.5 degrees Celsius is so fatal for the planet. It's really easy to look at a range of numbers and presume that just because Teresa range, things on the range must be linear. Water freezes at 32°C. If you raise it to 33°C, it will melt, guaranteed, all of it will, not just 1 degree's worth. So there will be a point, a temperature, where 1 degree causes a watershed change. Late biologist Stephen Jay Gould described a change like this to have punctuated equilibrium to reach kind of a clamping effect. Okay, technically, the ice holds the surrounding water at 32°C steadily until it has melted. Well, 1.5°C isn't expected to ruin the Earth on its own. 1.5°C will cause harm, but can also cause the Earth to heat up further. Things like the snow cover will be reduced, and permafrost will melt and emit methane. From there you get further warming. So 1.5°C is just the start. From there also realize that it's easier to break things than fix things. Plants and animals dying can be replaced by warmer weather life, but the death will happen faster than the new life can move in. More so given the time scale involved. Normally 1.5°C takes centuries versus decades. That's an average increase, not just over a few days. This usually means much more than 1.5 degree extremes, which overall add up to a 1.5 degree increase. That's little bit of temperature is actually a ton of energy sticking around. This extra energy can concentrate into certain effects, resulting in things like really big storms, droughts, rising sea levels, and so on. Moreover, things like animals not liking the heat, plants dying to frost, or fish not getting enough oxygen are related to these temperature swings. Instead of thinking about it in terms of temperature like the temperature outside on a given day, think about it in terms of energy. How much energy would you need to put into a bathtub full of water to raise its temperature by 1.5 degrees? How about a swimming pool? How about the entire Earth's atmosphere? When you look at it that way, it's easy to see why we expect huge storms, major changes in weather patterns, etc. The amount of extra energy we've been adding to the atmosphere is enormous, because at the temperature of -1–2 degrees the ice freezes, and at the temperature of +0.5 degree Celsius ice melts. Frozen ice is white and reflects most of the sunlight that hits it back into space. Melted ice is nearly black and it absorbs most of the sunlight that hits it and turns it into heat. That feedback loop doesn't stop until all the ice is gone. If climate change kills us, it will be because of the feedback loops that we started and can't stop. What helped me is the following. The global average temperature is pretty much the sum divided by the size of the planet. If the global average rises by 1.5 degrees, the amount of energy that just got added to the system Earth is 1.5 times the size of the planet. That's a huge amount, and it's not like anything else in the past where it got hotter in some places but also colder in others. Here it's getting hotter everywhere and it's staying that way everywhere. I'm not a climatologist, but the way I choose to visualize it is exchange of energy. Imagine 1.5 extra degrees in a pint of water, no big deal. Now imagine 0.15 extra degrees in our oceans, that's 1,386 million cubic kilometers of water. A cubic kilometer of water equals about 264 billion gallons. That is a shit ton of extra energy, and since our weather is all about the exchange of heat around the planet, well, you get the idea. Simplistic, but this is ELI5. Imagine you have a cup of water that is filled to the brim. Take that cup and pour it into another cup of the same size without any problems. But once you start adding a little bit more water, then you have problems. You start overflowing and making messes. The planet is currently in balance with respect to the amount of energy it can sustain. Once you start pumping more energy into the system, the cups start to overfill, and we see that as climate change. Think about it in the other direction. I think it was about 4 degrees cooler during the Ice Age that had glaciers covering all of Canada and stretching down to New York. So what seems like small numbers represent massive amounts of change in the environment. I think that one of the biggest communication errors that people advocating for climate change mitigation have done is not properly explain what these average temperature numbers actually mean. Try to think of temperature as energy. What we really mean when we say that the world is getting warmer is that there is more energy in the system. The system itself is kind of closed when you think globally. The frequency and severity of the storms we are seeing is a result of this increase in energy. The natural way that the planet balances out this energy is through storms, so when there is more energy, there are more storms and they are stronger. It's a sliding scale. 1.5°C is the point where bad things start to happen. We need to reduce our emissions by 98 of current levels to break even and stop the temperature from increasing. So 1.5°C is a goal. If we do nothing, temperature will continue to increase until human civilization collapses to the point where we have reduced our emissions by 98. At that point the ice caps will have melted and sea levels will have risen by 200 feet or more. I'm gonna try a whole different explanation. If you raise your own body temp by 1.5 degrees Celsius you get sick. We call it a fever. Your fine-tuned complex body isn't equipped to handle these conditions long term. Same goes for all other complex organisms, ecosystems etc., which all depend on a certain balance not being disturbed for too long or it all starts to break down and whole thing kinda collapses. Might not be the best analogy but I think it kinda works. In the peak of the last ice age, 20,000 years ago, the global temperature was about 6 degrees lower than today. Back then, half of Europe was a glacier, and sea levels were 130 meters lower than now. While this does not explain the why of your question in scientific terms, it puts the effect of a relatively small temperature change into perspective. In a way, 1.5 degrees equal 1/4 of the difference between nice warm summers and kilometers of ice. It changes how much water can be up in the sky. So that means it can go longer without raining in places where the environment has gotten used to a certain amount of rain. This can make it hard for some plants to grow and can make forest fires more common and bigger. It also means when it does rain there's more water in the sky to fall. Places not used to a lot of rain at once can get flooding in ways we aren't ready for. Think back to high school and your score at the end of the year is an 80 with 2 more tests to go. If you've been getting 80s all year, how abnormally high does a single test score need to be to get to a 95 average for the year? The average score over a dozen tests weight can be compared to average day temperatures over hundreds of years weight. How fucking highly abnormal would it need to be to move up 1.5°C? 5°C? I think the way you are thinking about it might be backwards. It's not that the Earth will increase by 1.5°C on average and then the temperature will cause problems. It's that 1.5°C is a goal that someone determined is feasible for the world to meet. Lower would be better. The other thing is that global climate and ecosystems are non-linear systems, meaning a small change can create a huge difference in outcomes. It takes a massive amount of energy it takes to raise the entire world, 1 degree. That single degree is not a constant, but an average, so the temperatures in some places can be much higher and some much lower. It just completely throws weather patterns out of whack around the world, and you get extreme weather events in both directions. Extreme droughts, extreme rains, and extreme cold and snow. The amount of energy that it takes to raise the entire Earth's surface by 1 degree is huge. That energy is now stored in the Earth's temperature and available to affect things like weather patterns including hurricanes, wind patterns, affecting climate change, ecosystem changes, leading to extinctions, melting of ice, etc. It's a ton of energy available to change things from how they currently are. It's not. Let's play a thought scenario. We find an exoplanet accessible by a wormhole on the moon. I know, not real, but it's a thought experiment. This planet is like Earth in every way possible, but it's 2 degrees Celsius warmer. The very people who are wearing tinfoil doomsday hats would be dancing in the streets at the discovery and selling their children to get a chance to move there. It is not fatal for life on this planet. The Earth has been hotter and there was still life. It certainly is fatal for many species, however, when their habitat disappears. It can be destructive for our human societies when food production struggles in large areas become inhospitable. It's the wars, famines and mass migration that are going to be catastrophic for our world as we now know it. The flora and fauna will change, as will the weather and erosion patterns. It's happened before. According to my understanding of the Earth's history, this next change will be just a blip in the endless series of changes. Please, who here thinks that modern man will not survive a 2 degrees rise? Anyway, what you really need to do is parse out and define what you mean by fatal. Please think about heat energy versus temperature. The amount of energy required to increase the Earth's temperature by 1 degree is about 25 billion times the energy released by the atom bomb at Hiroshima. We're currently releasing about 300,000 Hiroshimas worth of energy a day from greenhouse gases. All of that energy has to go somewhere. E.g. heat waves, ocean heating, extreme storms, etc. 1.5 degrees Celsius is a global average. You can easily double that for being on land. Double again for being far north. Now it's 6 degrees hotter at the North Pole, all the ice is melting, and the dark ocean absorbs heat instead of reflecting it from the bright ice shield. Now you have 3 degrees to 4.5 degrees Celsius in Northern Europe, and now it's getting hotter, even if you stopped emitting greenhouse gases. This was the description that helped me the most. Today we averaged 29 days below freezing at place wherever. If the average temperature rose 2 degrees, then we'd only averaged 19 days below freezing. That means an average of 10 more days per year where ice is melting. So a small increase in average temperature could result in many more days of ice melting each year. An increase in 1 degree Celsius doesn't mean every place gets 1 degree more all the time, which would also be very bad. Some places get 10 degrees more for 10 of the year, which can dry out lakes or result in much more rain somewhere else. If you sit in a 200 degrees oven for just a few minutes, your average room temperature for that day barely increased, but you would probably try to avoid that. Average temperature is really just a measure of the average energy in the system. A relatively small increase in average temperature still represents a huge amount of added energy to the whole system. That added energy manifests in more severe weather, i.e. more extreme hots of course, but also more extreme colds, more extreme droughts, floods, winds, etc. etc. Here's a comment from Administrative Hoodie from 3 months ago that sums it up rather well, and is probably the single greatest thing I've read on Reddit. I read about how summer coming even one day later stopped a certain bug from hatching in time to pollinate. The lack of pollination stops new life from growing, which then causes a famine of the local animals, which also stops them from stamping the soil, fertilizing it, which limits new growth even further. Now whole areas are essentially dead.